Good morning, students. So, till now we discussed about the catalytic property, activation energy, and integrated rate equations for both zero order as well as first order reaction related problems, right? So, till here we solved. So, let's begin with the remaining problems. I hope you have practiced all these problems well. And if you have any doubts, you can ask me now. Okay. We'll keep the discussion session in the later. So here is a problem. By increasing the temperature by 10 degrees Celsius, the rate of forward reaction is is increased by a factor of 2. Okay. The rate of backward reaction by this increase in temperature is. See, try to understand the question. By increasing the temperature by 10 degree Celsius. So, temperature coefficient here is 10 degree Celsius. The rate of forward reaction ಹಾಗೂ the rate of backward reaction ಏನಾಗುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. If the equilibrium is increased by a factor of 2. It is in equilibrium. That means forward reaction will be equal to backward reaction. So whenever there is a word equilibrium comes, that means it is in the dynamic equilibrium. Forward reaction and backward reaction will be in the same manner. Okay. So therefore, equilibrium increased by factor 2 andre ಏನಾಗುತ್ತೆ, it remains unaffected, because if it is a forward single directed reaction, then it would have affected, but as they have mentioned it is in equilibrium, then it remains unaffected. Therefore option it also one more option is there, it remains unaffected, but it is the factor of 2. Let's see, here it is some 2 is given. Option B, increased by a factors greater than 2. No, it remains unaffected. Therefore, it is not greater than 2. Decreases by a factor lesser than 2. No. Then option D, it is also increased by a factor of 2. Yes. ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಿದ್ದಾರೆ, ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ಫ್ಯಾಕ್ಟರ್ 2 ಅಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ at the same time whenever it is in the equilibrium, the backward also increases by 2. Therefore, option D is more relevant to this question than option A. Here you might have got confused. Remains unaffected. Yes, it is remaining unaffected, but 2 in the increase ಆಗ್ತಾ ಇದೆ. Therefore, backward direction allu kuda increase ಆಗುತ್ತೆ. Therefore, option D is correct. Then the second question is, in a reaction, the threshold energy is equal to. So what do you mean by threshold energy? Threshold energy is an inbuilt energy which will be present along with the reacting molecules as well as the product molecules. So that is, it includes activation energy, normal energy of the reactants, activation energy minus normal energy of the reactants, only activation energy, and normal energy of the reactants. Okay, so activation energy plus normal energy of reactants. Activation energy is the energy of reactant, that is minimum amount of energy required to form an intermediate. For that, normal energy of the reactants involved is also important. Therefore, the summation of these two is called as threshold energy. Since it is a threshold energy, option A is correct. Okay. Next. Catalyst decomposition of hydrogen peroxide is a dash order reaction. Okay, so catalyst decomposition of hydrogen peroxide, that is hydrogen peroxide will be decomposed to give water and oxygen. So this is used by with the help of catalyst. Therefore, it is a first order reaction. See, decomposition of H2O2 gives rise to H2O plus half O2. Okay, so this is a balanced chemical equation, and the rate order of the reaction can be written as K is equal to R is equal to K into proportionality constant, that is a rate constant, H2O O2, and since we do not have any stoichiometric coefficient here, the right one. So R is directly related to this first order. Okay. ಗೊತ್ತಾಗ್ತಿದೆನಾ? Right. Next 54. A reaction having equal energies of activation for toward and reverse reaction has. See, a reaction having equal energies. Activation energy ಏನಾಗಿದೆ ಎರಡಕ್ಕೂ equal ಇದೆ. Toward and reverse reaction. That means forward as well as backward reaction ಗೆ ಏನಾಗಿದೆ activation energy is equal. That is EA is equal to both forward and backward reaction. Therefore, this has change in free energy is equal to 0, change in enthalpy is equal to 0, change in enthalpy, free energy as well as entropy is equal to 0, and change in entropy is equal to 0. See, backward and forward reaction ಗೆ ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ activation energy ಅಂತ ಬಂದಾಗ the change in enthalpy can be given as energy in the forward reaction and backward reaction will be equal to 0. Therefore, in terms of energy anta ನಾವು ಹೋದಾಗ we need to go for enthalpy. Therefore, change in enthalpy is equal to 0. Okay, ಯಾಕೆ ಅಂದ್ರೆ ಅವರು ಇಲ್ಲಿ activation energy ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. So, energy of forward reaction and backward reaction both are same ಅಂತ ಹೇಳ್ತಿದ್ದಾಗ ಅದು ಏನಾಗಿರುತ್ತೆ equal to 0. So, same values ಇದ್ದಾಗ ಅದನ್ನ subtract ಮಾಡಿದಾಗ 0 ಬರುತ್ತೆ. Therefore, option B is correct. Change in enthalpy is equal to 0. Okay. Next is the activation energy of a reaction can be determined from the slope of which of the following graphs? The graphs they have given, one is ln k versus 1 by t by ln k versus 1 by t, ln k versus t, ln k by t versus t. Okay. So what is the equation activation energy relation ಮತ್ತೆ temperature ಗೆ correlate ಮಾಡುವಂತ equation ಯಾವುದು? Arrhenius concept ಅಲ್ವಾ? Arrhenius equation. According to Arrhenius equation, K is equal to A into e to the power of minus EA by RT. Since they have mentioned ln, let us take natural log on both sides. Then what we will get? Ln K is equal to ln A into e to the power of minus EA by RT. So this is in the form of log A into B. Because log A into B is equal to log A plus log B. This you know, right? So ಇದೇ ತರ ಇದನ್ನ expand ಮಾಡ್ತೀನಿ. Ln K is equal to ln A plus ln E to the power of minus A by RT. So ln A ಹಾಗೆ ಇರಲಿ. ಇದು ನೋಡಿ log A to the power of B ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ. Log A to the power of B is nothing but B log A ಅಲ್ವಾ? So ಇಲ್ಲಿ B ಅಂದ್ರೆ ಏನು? Minus EA by RT. Since minus into plus is minus, I have written minus directly here. Power ಅಲ್ಲಿ ಇರೋದನ್ನ ಇಲ್ಲಿ ಬರಿಬೇಕು ನೋಡಿ ಇಲ್ಲಿ A to the power of B first ಬರುತ್ತೆ then log A. ಅದೇ ತರ B is nothing but this minus A by RT then ln E. Ln E value is nothing but constant, that is 1. Therefore, ln K is equal to ln A minus EA by RT ಆಯ್ತು. Okay. ಇದರಲ್ಲಿ ನೋಡಿ the graph, if we plot a graph, then we will get ln K versus T, that is 1 by T. Since it is in the denominator, we will get the graph that is ln K versus 1 by T. Therefore, option A is correct. Okay, ಇಲ್ಲ ಇದೆ ನೋಡಿ. Next, when initial concentration of a reactant is doubled in a reaction, its half-life period is not affected. ನೋಡಿ initial concentration ಏನು ಮಾಡ್ತಿದ್ದಾರೆ double ಮಾಡ್ತಾ ಇದ್ದಾರೆ. Therefore, its half-life will not be affected. Then the order of the reaction is, we have two order of the reaction. First one is zero order, then first order. Half-life for zero order and first life ಬರ್ಕೊಳ್ಳೋಣ. Zero order ಗೆ ಏನು ಹೇಳುತ್ತೆ half-life period? T half is equal to molar concentration of R divided by 2K. Similarly, for first order, T half is equal to 0.693 divided by K. which is independent of initial concentration. See, zero order alli adu initial concentration mele depend agide. Square bracket indicates molar concentration, reactant. In the first order, we do not have any R here, that is reactant ugly, product ugly, concentration illa factor idralli. Okay, so if the initial concentration of the reactant is doubled, its half life is not affected. ಏನು affect ಆಗ್ತಾ ಇಲ್ಲ. Therefore, option D is correct. First order ಅಲ್ಲಿ ನಮಗೆ ಇದ್ರ ಬಗ್ಗೆ ಅಂದ್ರೆ concentration relation ಯಾವುದು ಇಲ್ಲ. Therefore, this is the right answer. First order. The rate constant of A to B is 6.0 into 10 to the power of minus 3 moles per second. If the concentration of A is 5 molar, then concentration of B after 20 minutes is, okay, so after 20 minutes ಏನಾಗುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. Okay, so here we can take it as the concentration of R is equal to K into T anta ತಗೊಳ್ಳೋಣ. Okay, K into T. ಇದು ಯಾವ basis ಮೇಲೆ? Okay, concentration of B. Only the concentration of B we are considering. B ಎಷ್ಟು ಕೇಳಿದ್ದಾರೆ after 20 minutes. Okay, is equal to K into T. Remaining we do not want. K value is 6.0 into 10 to the power of minus 3 into time is how much? 20 minutes. But here you have to concentrate. Nodi A to B adaga adu per second, moles per second. Okay. Similarly, B matra kelsidare. Illi A to B adaga eshtiದೆ concentration. B adaga eshtu. A is 5 molar. Similarly, how much for B? After 20 minutes. Okay. So minutes ina illi ನಾವು time 20 minutes ಇದೆ, seconds ಗೆ convert ಮಾಡಬೇಕು. Okay, into 60. Because here it is in second. Let us calculate this. 6.0 into 10 to the power of minus 3 into 6 2s are 12. 1200 is equal to, so how much it is? 6 divided by 1000. So 6 divided by 1000. ನೋಡಿ ಇದು ಕೆಳಗಡೆ ಹೋದಾಗ plus 3 ಆಗುತ್ತೆ into 1200. 2 zeros cancel. 72 divided by 10. Okay, 12 6. Just a minute. I think this is not 6.0. This is 0.6 into 10 to the power of minus 3, not 6.0. Okay. So 0.6. This is 0.6. Right. So now we can calculate. Yes. So there was a mistake in the question itself. This is not 6, this is 0.6. Since you are not supposed to use the calculator, try to solve it without calculator. Okay, 20 into 60 is 1200, 0.6. This 10 to the power of minus 3 have taken in the denominator, that becomes 1000, 10 to the power of plus 3. So 2 zeros cancels. 0.6 by 10 is 0.06 into 12 is 0. Or else here you can take 0.6 into 12 is 7.2 divided by 10, that is nothing but 0.72 molar is the concentration of B. Okay, therefore option B is correct. Yes, very good. Next, So the addition of a catalyst during a chemical reaction alters which of the following quantities? Okay. Catalyst ಅನ್ನು ಆಡ್ ಮಾಡೋದ್ರಿಂದ ನಮಗೆ ಯಾವ ಕ್ವಾಂಟಿಟೀಸ್ ಅಲ್ಲಿ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ? See, we have activation energy, entropy, internal energy and enthalpy. So you might have studied about this graph. Okay. The reactant, like this, it is going to give a product. Whatever distance here you are going to get is nothing but the energy required, that is activation energy. So if we use a catalyst, then the energy can be decreased and very soon we are going to get the products. Okay, this is the activation energy with using catalyst. Therefore, catalyst affects in reducing the activation energy. Therefore, option A is correct. Entropy is related to this one, randomness of the molecules. Internal energy, that is the energy which is present or associated with the reacting molecules, and enthalpy is the change in heat energy from the system to the surrounding or vice versa. Okay, therefore option A is more relevant. Last but one question. A first order reaction has a specific reaction rate of 10 to the power of minus 2 per second. That is reaction rate. That means K is equal to 10 to the power of minus 2 per second. How much time will it take? That means time we have to calculate for 20 grams of a reactant to reduce to 5 grams. That means initial concentration is 20 grams and finally how much it is left? 5 grams. So which formula I have to use? First order reactions, that is K is equal to 2.303 divided by T into log R0 divided by R. T you need to calculate, therefore rearrange the formula. 2.303 divided by T time, K 10 to the power of minus 2. Log initial concentration is 20 grams, final is 5 grams. Gram cancel, 5 ones are 5 fours are. Okay, so 2.303, if this 10 to the power of minus 2 goes to the numerator, it becomes 10 to the power of plus 2, that means 100. Then log 4 value is 0.6020. Few log values you have to practice, okay, because calculator as well as log tables will not be allowed. So idina multiply madana, okay, 2.303 into 0.6020 into 100. How much you are going to get? It is 138.6 seconds time. Therefore option A is correct. You are understanding, no, Subramanya? 10 plus 2. Where it is 10 plus 2? The catalyst is an external agent which enhances the rate of the reaction. Andre, ಈಗ 1 hour ಅಲ್ಲಿ ನಡೆಯುವಂತ reaction ಅನ್ನ just at 15 minutes ಅಲ್ಲಿ ಮುಗಿಸುವಂತದ್ದು. ಅಂದ್ರೆ rate, speed ಅನ್ನ slow ಮಾಡುತ್ತೆ. Okay, sorry, fast ಮಾಡುತ್ತೆ. So that process will be taken with the help of catalyst. ಈಗ bio catalyst ಗಳಿದೆ, inorganic catalyst ಗಳಿದೆ. For example, Haber's process. Haber's process ಅಲ್ಲಿ ಈಗ just ಮ್ಯಾಮ್ P ಬ್ಲಾಕ್ ಮಾಡ್ತಾ ಇದ್ದಾರಲ್ವಾ, Haber's process ಅಲ್ಲಿ ನಾವು ಒಂದು catalyst ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. That is, Haber's process is nothing but manufacturing ammonia, preparation of the ammonia. Okay, so ಅಲ್ಲಿ ನಾವು ಯಾವುದು catalyst ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ Haber's process ಅಲ್ಲಿ? Subramanya? Yes, which catalyst we are using in the preparation of ammonia from nitrogen and hydrogen? No, hydrogen is not a catalyst. It is one of the reactant. There we are using iron as a catalyst. ಓಕೆ, ಸೊ ಅಲ್ಲಿ ಆ ಥರ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಂಡ್ ಸಿಮಿಲರ್ಲಿ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ ನೀವು ಬಯಾಲಜಿಯಲ್ಲಿ ಓದಿರ್ತೀರಲ್ವಾ, ಸಮ್ ಕೆಟಲಿಸ್ಟ್ ವಿಲ್ ಬಿ ಯೂಸ್ಡ್ ಇನ್ ಆರ್ಡರ್ ಟು ಕನ್ವರ್ಟ್ that is sucrose into glucose and fructose. ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಅಲ್ಲಿ ನಾವು ಕೆಲವೊಂದು ಕೆಟಲಿಸ್ಟ್ ಗಳನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆರ್ ಪ್ರೋಟೀನ್ ವಿಲ್ ಬಿ ಡಿಕಂಪೋಸ್ಡ್ ಇಂಟು ಅಮೈನೋ ಆಸಿಡ್ಸ್. ಓಕೆ, ಇದರಲ್ಲಿ ಪೆಪ್ಸಿನ್ ಅನ್ನೋ ಕೆಟಲಿಸ್ಟ್ ಅನ್ನ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, so biocatalyst, naturally in our body whenever we consume proteins, pepsin enzyme will be activated, that is called enzymatic catalyst. ಈ ತರ catalyst ಗಳ ಏನ್ ರೋಲ್ ಅಂದ್ರೆ the process will be fastened ಅಂತ. Understood? And what about this problem? You understood, right? If you have any doubts, you can ask me. Yes. So this is our last question from this chapter. That is, when initial concentration of the reactant is doubled, the half-life period of a zero order reaction is. The initial concentration of the reactant is doubled. Half-life period of a zero order reaction. Half-life of zero order ಏನು? Order reaction is that is T half is equal to 0. Molar concentration of R divided by 2K. That means initial concentration of the reactant is double. Andre T half-life of zero order is directly proportional to initial concentration. I'll take only numerators. Initial concentration ಗೆ ಅದೇನಾಗಿದೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ರಿಲೇಟ್ ಆಗಿದೆ, whereas rate constant ಗೆ inversely proportional. So direct ಆಗಿ ರಿಲೇಟ್ ಆಗಿರೋದ್ರಿಂದ if the initial concentration is doubled, ಇದನ್ನ ಡಬಲ್ ಮಾಡಿದ್ರೆ ಇದು ಕೂಡ ಏನಾಗುತ್ತೆ ಡಬಲ್ ಆಗುತ್ತೆ. Okay, so that means option B is correct. If this is, as it is directly related, if this is doubled or tripled, the same thing happens in case of the half-life of the zero order reaction also. Understood? Yes. So this is about chemical kinetics, and next we will start with the surface chemistry as we have finished that chapter. Before going to the problems, let us see what are all the contents you need to observe and practice in that chapter. Okay, so few more questions from this chapter you are going to get an assignment, as an assignment. Okay, there you can have a practice, and if you get any doubts you can ask me. Right. So next is our surface chemistry. So this is one of the chapter which comes under physical chemistry, that deals with the surface phenomenon. So whatever you are going to study in this chapter is all about the surface phenomenon. Surface phenomenon illi neevu oddira. So this chapter has no much problematic questions. Idralli problematic illa. So theory based chapter it is. So the questions which come in your entrance exam will this chapter has less weightage in that, but still you have to practice this. So let us see what are all the concepts that are present in this. So as I told you, this is a branch of chemistry that deals with the nature of surface and the phenomenon that occurs on the surface of the solids and liquids. Okay, solids and liquids surface ಮೇಲೆ ಏನೇನು phenomenon ಗಳು ನಡೆಯುತ್ತೆ, process ಗಳು ನಡೆಯುತ್ತೆ, so that you are going to study in this chapter. And the molecular forces at the surface of solids are unbalanced. Okay, always the molecular forces that are present on the solid surface. So this is the compact arrangement in the solids, and these molecules energy are unbalanced. The gaps between these molecules agirbodu, which are called voids, that you have studied in your first chapter. Okay, so in order to satisfy this unsaturation or unbalanced force, their surface attracts gas molecules or liquid. Okay, so that's why the surface phenomenon takes place. In order to balance that force, iದೇನು unbalanced force ಇದೆ ಅದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಕ್ಕೆ ಅದೇನ್ ಮಾಡುತ್ತೆ, ಆ ಸರೌಂಡಿಂಗ್ ಅಲ್ಲಿ ಇರುವಂತಹ ಗ್ಯಾಸಸ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಲಿಕ್ವಿಡ್ಸ್ ಆಗಿರ್ಬೋದು, ಅದನ್ನ ತನ್ನ ಗ್ಯಾಪ್ ಅನ್ನ ಫಿಲ್ ಮಾಡ್ಕೊಳ್ಳಕ್ಕೆ attract ಮಾಡುತ್ತೆ. And this attractive force and this process of attraction is called as adsorption. Okay, adsorption anta ಹೇಳ್ತೀವಿ ಅದನ್ನ. So this happens due to balance the unsatisfied force or the surface area, ಅದಕ್ಕೋಸ್ಕರ ಅದು attract ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. That is called as adsorption. Okay, and the substance that adsorbs on the surface is called adsorbate. ಇಲ್ಲೇನು ಈ particles gas ಅಥವಾ liquid ಇದಕ್ಕೆ adsorb ಆಗುತ್ತಲ್ಲ, so these particles are called adsorbate. Whereas the surface which is involved in the adsorption process is called as an adsorbent. Okay, both together form adsorption process, right? And for example, when carbon dioxide is adsorbed on charcoal, okay, the charcoal ide anta itkolona. Okay, so this adsorbs carbon dioxide from the surrounding. So here carbon dioxide will be the adsorbate and charcoal will be the adsorption. Adsorbent, and together forms the process called adsorption. Okay. So adsorption is a surface phenomenon and the concentration of adsorbate is high on the surface of the substance. Okay, so concentration of the adsorbate will be always high on the surface of the substrate than in the bulk. Only on the surface it is going to adsorb, not in the core of the molecule. For example, whenever if you dip the chalk in a ink, the chalk surface will be colored, but the center of the core of the chalk will be still white in color. ಈಗ ನೀವು ಇಂಕ್ ಅಲ್ಲಿ ಅದನ್ನ ಡಿಪ್ ಮಾಡಿ ಅದನ್ನ ಬ್ರೇಕ್ ಮಾಡಿದ್ರೆ ಮಧ್ಯದ ಪಾರ್ಟ್ ವೈಟ್ ಹಾಗೆ ಇರುತ್ತೆ. Only the surface will be blocked with the colors. Okay, always the adsorption takes place on the surface, so that's why it is called as a surface phenomenon. It is not a bulk phenomenon. ಮೇಲ್ಗಡೆ ಮಾತ್ರ ಇರುತ್ತೆ, ಇನ್ನರ್ ಕೋರ್ ತನಕ ಹೋಗೋದಿಲ್ಲ. Okay. On the other hand, the absorption, one more word you might have heard, absorption anta ಹೇಳ್ತೀವಿ ಅದನ್ನ. Absorption and adsorption both are different. See, this is a bulk phenomenon. For example, ಈಗ ಸ್ಪಾಂಜ್ ನ ನೀವು ತಗೊಂಡು ನೀರಲ್ಲಿ ಅದ್ದಿದ್ರೆ ಪೂರ್ತಿ ಅದು ಇರುವಂತ ಎಲ್ಲ ಪೋರ್ಸ್ ಕೂಡ ಕವರ್ ಆಗುತ್ತೆ. ದಟ್ ಇಸ್ ಬಲ್ಕ್ ಫೆನೋಮಿನನ್, ಇನ್ನರ್ ಕೋರ್ ತನಕ ಹೋಗುತ್ತೆ. Whereas chalk ಅಥವಾ charcoal ಅನ್ನ ಡಿಪ್ ಮಾಡಿದಾಗ only on the surface. Okay, so this is a surface phenomenon. So that is a difference. Okay, so here the concentration will be uniform. The concentration will be uniformly spread throughout the molecule or the substrate, whereas here it is not uniformly spread. So concentration is more towards the surface, is high only on the surface, not on the bulk, or it is not uniform. Okay. For example, absorption of water by anhydrous calcium chloride, ಡೆಸಿಕೇಟರ್ಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ನಾವು, ಮಾಯಿಶ್ಚರ್ ಅನ್ನ ಅದು ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. anhydrous calcium chloride ಏನಿದೆ, so that is the example for absorption. Okay, whereas here the charcoal or chalk and water, chalk and ink, charcoal and carbon dioxide, these are the examples for adsorption process. Okay, see, if I heat this charcoal, okay, once idu carbon dioxide na absorb ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ಇದರ ಸರ್ಫೇಸ್ ಮೇಲೆಲ್ಲ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಬ್ಸಾರ್ಬ್ ಆಗಿರುತ್ತೆ ಈ ರೀತಿ, only on the surface, not on the inner core. If I heat this, whenever I increase the heat, the adsorbed molecules get dissolved. ಅಂದ್ರೆ ಆ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಆಗಿರುವಂತ ಫೋರ್ಸ್ ಏನಾಗುತ್ತೆ, ಡ್ಯೂ ಟು ದ ಹೀಟ್ ದ ಪೋರ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಓಪನ್ ಅಂಡ್ ಅಡ್ಸಾರ್ಬ್ ಆಗಿರುವಂತ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಎಲ್ಲ ಎಸ್ಕೇಪ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದೇರ್ ಫಾರ್ ದಿಸ್ ಪ್ರೋಸೆಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಡಿಸಾರ್ಪ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದಟ್ ಈಸ್ ದ ರಿವರ್ಸ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್, ಉಲ್ಟಾ. The force or the heat, that is the equilibrium, that is the rate of adsorption and desorption are always equal rate ಅಂದ್ರೆ process. For example, ಈ ಗ್ಯಾಸ್ ಡೆಪಾಸಿಟ್ ಆಗ್ಲಿಕ್ಕೆ ಒಂದು 5 minutes ಬೇಕು ಅಂದ್ರೆ ಅದು ವಾಪಸ್ ಅಲ್ಲಿಂದ ರಿಲೀಸ್ ಆಗಕ್ಕೆ ಕೂಡ 5 minutes ಬೇಕು, and the energy how much it is utilized will be released in the same amount. Okay, so ಎರಡು ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ, heat energy as well as rate of the reaction, both adsorption and desorption. Desorption is a reverse adsorption process. Yes. So coming to the heat of adsorption or the extent of adsorption, if we say, during adsorption attractive forces develop between the adsorbent and adsorbate. Okay, and this results in the release of energy. ಅದೇನಾಗಿರುತ್ತೆ, ಆಕ್ಟಿವ್ ಫೋರ್ಸಸ್ ಡೆವಲಪ್ ಆಗಿರೋದ್ರಿಂದ ದ ರಿಸಲ್ಟ್, ಆಸ್ ಅ ರಿಸಲ್ಟ್ ವಾಟ್ ವಿ ವಿಲ್ ಗೆಟ್, ದ ಎನರ್ಜಿ ರಿಲೀಸ್ ವಿಲ್ ಬಿ ದರ್. Hence adsorption is generally exothermic process. It is an exothermic process. Adsorption always involved in the release of energy, involved in the release of heat energy in the form of heat. Therefore it is an exothermic process. Exothermic ಆಗಿರೋದ್ರಿಂದ delta H will be always negative. Okay. Then extent of adsorption bandra, so that this can be expressed with the help of theta, that is number of adsorption sites occupied divided by number of adsorption sites available. Okay, so ಈ ತರ express ಮಾಡ್ತೀವಿ. So this is the extent of adsorption. So the ratio of mass of adsorbate to mass of adsorbent ಅಂತ ಕೂಡ ಹೇಳ್ಬೋದು. So that can be expressed with the letter theta. Mass of adsorbate to mass of adsorbent ಅಂತ ಕೂಡ ನಾವು ಇದನ್ನ express ಮಾಡ್ಬೋದು. And characteristics of adsorption. So it is a surface phenomenon, as I told you, due to the selective holding of gas or liquid molecules by the surface of the solid only. It causes higher concentration only on the surface, not on the bulk, and it is a spontaneous process. It happens itself without using an external agent. Okay, so that's why it is called a spontaneous process, and it is accompanied by the evolution of heat. So it is an exothermic process. Always the evolution of heat takes place. Okay, so as the residual forces acting along the surface of the adsorbent decrease, heat evolved on the adsorption. Okay, and adsorption is accompanied by the decrease in enthalpy and decrease in entropy as well as decrease in free energy. All are going to decrease. That is, since it is exothermic, negative entropy, ನೋಡಿ spontaneous ಆಗಿರೋದ್ರಿಂದ entropy, change in entropy is always positive. Change in entropy negative, since enthalpy becomes negative, and change in free energy is also negative. Larger the specific surface, greater will be the energy. So since it is surface phenomenon, larger the surface, higher will be the adsorption. So these are some characteristics that you have to remember, which will be helpful to solve the questions. And we have two types of adsorption. Coming to the types, we have two main types called physical adsorption, or it is also called as physisorption. chemical adsorption, or it is also called as chemisorption. These are the main two types of adsorption. Okay. See, physisorption, the force of attraction that is present in physisorption is weak van der Waals force. Weak van der Waals force will be there, whereas in the chemical adsorption or chemisorption, there is a strong, especially covalent bond will be present. That is the main difference. And the heat of adsorption, that is enthalpy, will be low here since it is the force of attraction is weak. Adu attract adaga release aguanta energy kuda kadme irutte. So that is ranging between 20 to 50 kilojoules per mole. Whereas here it is very high, that is more than 50 kilojoules per mole, around 400 to 500 atara irutte. Okay. So all gases can be absorbed. This is not specific. This is non-specific. A surrounding alli just a force and a balance madlikke yava gases utilize madkolutta available irutto adanna utilize madkondo adu adsorption agutte. So it is not specific. Whereas here it is very specific, highly specific, because it is involved in the formation of bond. That means exchange of electron has to take place. Therefore, it is highly specific in nature. Okay. And no compound is formed between the adsorbent and adsorbate. No compound formation takes place. Whereas here a particular compound will be formed since it is again a covalent bond, particular reactant. So this is reversible. Once the adsorption takes place by providing heat, providing this much energy, the desorption takes place and the adsorbed gases can come back from the adsorbent. Whereas once the compound is formed, we can't get the reactants back because all the chemical changes occurs on the surface of the adsorbent. Therefore, it is irreversible. Okay, this is irreversible. And it takes place at low temperature. Whereas this requires high temperature. And the process, the rate of reaction rate is fast since it is non-specific and no compound is going to form, and it is comparatively slow. Okay, so these are some topics that you have to keep in your mind. That is in the introduction part. As an introduction part, you have to keep it in your mind to solve some problems related to this introduction part. And again on the basis of the types, differences with examples. Okay. So let us solve the questions. So here is your first question. When the temperature is raised, the viscosity of liquid decreases. So this is because, see, this is a best example where you can observe in your daily life, that is during especially this season, winter season alli ಏನಾಗುತ್ತೆ, ghee ಆಗಿರ್ಬೋದು ಅಥವಾ coconut oil ಆಗಿರ್ಬೋದು, so they get solidified, they become very viscous, ಒಂಥರ ಗಟ್ಟಿ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಈ ತುಪ್ಪ ಎಲ್ಲ ಯೂಸ್ ಮಾಡೋಕ್ಕೂ ಮುಂಚೆ ಈ ವಿಂಟರ್ ಸೀಸನ್ ಅಲ್ಲಿ ತುಂಬಾ ಗಟ್ಟಿ ಆಗಿರುತ್ತೆ. ಸೊ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ, ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು ಅವಾಗ ಬಿಫೋರ್ ಯೂಸಿಂಗ್? ತುಪ್ಪ ಆಗಿರ್ಬೋದು ಅಥವಾ ಕೊಕೊನಟ್ ಆಯಿಲ್ ಆಗಿರ್ಬೋದು ಗಟ್ಟಿ ಆದಾಗ ಏನ್ ಮಾಡ್ತೀವಿ? Yes, heat. So we are going to heat it. So that means the viscosity of that liquid is going to decrease whenever the temperature is raised. ಹೌದಾ? ಇದು ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ. ಸೊ ಇದು ಯಾಕೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಯಾಕೆ ಹಾಗಾಗತ್ತೆ ಅಂತ. So decreased volume of the solution. No. Increase in temperature increases the average kinetic energy of the molecules. Yes, so as you have studied in your first PUC kinetic molecular theory, kinetic energy is directly related to temperature. When the temperature increases, kinetic energy also increases. That is nothing but energy released by the movement of the particles, which overcome the attractive force between them. What do you mean by viscosity? See, this is the force that resists the liquid to flow. Alva, this is the force of a molecule, force from the molecule, force of resistance to flow. ಅಂದ್ರೆ ಫ್ಲೋ ಆಗೋಕ್ಕೆ ಬಿಡಲ್ಲ, ಅದು ರೆಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ, ತಡೆ ಹಿಡಿಯುತ್ತೆ. ಸೊ ಅಂತ ಲಿಕ್ವಿಡ್ ಅನ್ನು ನಾವು ಹೀಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಆ ಪಾರ್ಟಿಕಲ್ಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಮಧ್ಯದಲ್ಲಿರುವಂತಹ ಫೋರ್ಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ದೇ ಸ್ಟಾರ್ಟ್ ಮೂವಿಂಗ್ ಹಿಯರ್ ಅಂಡ್ ದೇರ್ ಡ್ಯೂ ಟು ದ ಇನ್ಕ್ರೀಸ್ ಇನ್ ಟೆಂಪರೇಚರ್. ಬೈ ದಟ್ ದೇ go far away from each other. That means they become able to flow. Therefore option B is more relevant. Let us see C and D. Decreased covalent and hydrogen bond forces. No, we do not know which type of force is especially present, but both they have mentioned. But this force doesn't is the only reason, do not the reason to flow by the flow of liquid. Okay, and increased attraction between molecules. No, so therefore option B is correct. Next, which one of the following is an incorrect statement for physisorption? Okay, what do you mean by physisorption? That is the adsorption between the gas and the solid or any other liquid and the solid. Physical adsorption, weak van der Waals force will be there. ಯಾವುದು ಇನ್ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಇಷ್ಟ ತನಕ ನಾವು ಫಿಸಿಸಾಪ್ಷನ್ ಹಾಗೂ ಕೆಮಿಸಾಪ್ಷನ್ ಡಿಫರೆನ್ಸಸ್ ಅಲಾಂಗ್ ವಿತ್ ದ ಕ್ಯಾರೆಕ್ಟರ್ಸ್ ನೋಡಿದ್ವಿ. ಅದರಲ್ಲಿ ಯಾವುದು ಇನ್ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್? It is a reversible process. Yes, it is a reversible process. It requires less heat of adsorption. Yes. It requires activation energy. Yes. No. See, activation energy is not required. Activation energy, just now in the previous chapter you have studied, this is the energy that is obtained, minimum amount of energy required to get an intermediate. But whenever we go for a chemical adsorption process, we have reactant, product and intermediate. But when it comes to the physisorption, here we are not going to get any product like a compound. Okay, therefore it requires activation energy is irrelevant to this question. And option D is it takes place at low temperature. Yes, low temperature li agutte. Therefore option C is incorrect statement for physisorption. The noble gases are adsorbed by. Noble gases andre non-reactive gases, obviously they involve in the physisorption. So this can be adsorbed by anhydrous calcium chloride. Just now I told anhydrous calcium chloride is involved in the absorption of moisture. Absorption process alli involve ಆಗಿರುತ್ತೆ, not adsorption. And ferric hydroxide is not involved in the adsorption of noble gases and even the concentrated H2SO4. Activated charcoal, coconut charcoal. Yes, activated charcoal involved in the adsorption of gases. Okay, this is an example for physisorption. So it is not specific. It is okay, not specific. ಯಾವ gases available ಇದೆನೋ ಅದನ್ನ adsorb ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Especially noble gas adsorption ಗೆ we use activated coconut charcoal. ಆಕ್ಟಿವೇಟೆಡ್ ಅಂದ್ರೆ ಆ ಚಾರ್ಕೋಲ್ ಅಲ್ಲಿ ಪೋರ್ ಅನ್ನ ಜಾಸ್ತಿ ಆಕ್ಟಿವೇಟ್ ಮಾಡಿರ್ತಾರೆ, ಹೀಟ್ ಮಾಡಿ ಅದರಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಡಸ್ಟ್ ಇದ್ರೆ ಅನ್ವಾಂಟೆಡ್ ಗ್ಯಾಸ್ ಇದ್ರೆ ಅದನ್ನ ರಿಮೂವ್ ಮಾಡಿರ್ತಾರೆ. ಸೊ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಕ್ಟಿವೇಟೆಡ್ ಕೋಕೋನಟ್ ಚಾರ್ಕೋಲ್. ಓಕೆ, ವಿಚ್ ಆರ್ ನಾಟ್ ಪ್ಯೂರ್ಲಿ ಸರ್ಫೇಸ್ ಫೆನಾಮಿನನ್. ಯಾವುದು ಪ್ಯೂರ್ ಆಗಿ ಸರ್ಫೇಸ್ ಫೆನಾಮಿನಾ ಇದರಲ್ಲಿ ಅಲ್ಲ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಓಕೆ, see, which are not, this is not D, this is B, sorry, absorption it is. Okay, yes, D, no, let me check. Surface phenomenon. See, absorption is not a surface phenomenon. This is bulk phenomenon. Viscosity is not a surface phenomenon. This is related to intermolecular force. Adsorption is a surface phenomenon. Viscosity and surface tension. See, surface tension is a surface phenomenon, but viscosity alla. ನೋಡಿ ಇದರಲ್ಲಿ ಇದು ಸರ್ಫೇಸ್ ಫೆನಾಮಿನನ್, ಇದು ಅಲ್ಲ. ಇದರಲ್ಲಿ ಸರ್ಫೇಸ್ ಫೆನಾಮಿನನ್ ಇದು ಅಲ್ಲ, ಇದು ಹೌದು. ಅಡ್ಸಾರ್ಪ್ಷನ್ ಇಸ್ ಅ ಸರ್ಫೇಸ್ ಫೆನಾಮಿನನ್ ಬಟ್ ನಾಟ್ ವಿಸ್ಕಾಸಿಟಿ. ಓಕೆ, ಪ್ಯೂರ್ಲಿ ಎರಡು ಅಲ್ಲದೆ ಇರೋದು ಅಂದ್ರೆ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಅಲ್ಲ, ವಿಸ್ಕಾಸಿಟಿನೂ ಅಲ್ಲ. ದೇರ್ಫೋರ್ ಆಪ್ಷನ್ ಎ ಇಸ್ ಕರೆಕ್ಟ್. ಓಕೆ, ಅಂಡರ್ಸ್ಟುಡ್ ಸುಬ್ರಹ್ಮಣ್ಯ? Yes. Then, animal charcoal is used in decolorizing color of liquids because it is a good, just a minute. Animal charcoal, I think question is incomplete because it is good. Yes, animal charcoal is used in decolorizing color of liquids because it is a good absorbent, oxidizing agent, reducing agent. No, this chapter is related to surface phenomenon. So either option A or option B should be our answer. Animal charcoal is used in decolorizing color. See, animal charcoal is a solid substance. Liquid is a adsorbate. Therefore, ಯಾವುದು ಇಲ್ಲಿ? This is a solid. So either gas or liquids will be used to adsorbate here. So therefore this is an adsorbent. Solids will be always an adsorbent and this is adsorbate. So now tell me, here animal charcoal is either adsorbent or adsorbate. Option B. Yes, correct. It is a good adsorbent. Yes. So what will be the effect of increase in temperature on physical adsorption? Physical adsorption ಗೆ ಟೆಂಪರೇಚರ್ ಅನ್ನ ಜಾಸ್ತಿ ಪ್ರೊವೈಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? See, for example, again I'll take charcoal and it has adsorbed gases towards its surface. ಇಲ್ಲಿ adsorb ಆಗಿದೆ. So this takes place at low temperature. Low temperature is favorable. Okay. So in such case, if I increase the temperature, what happens? All the adsorbed gases get dissolved. ಹೊರಗಡೆ ಹೋಗ್ಬಿಡುತ್ತೆ. Okay. So if I increase the temperature, the physical adsorption is going to decrease. Therefore, option A is correct. It is going to decrease. Okay. So then is which of the following statements about chemisorption is not applicable? So this you people just observe the options and tell me as if you have as you have just now you have studied about the differences between physisorption and chemisorption. ಈಗ ತಾನೇ ಅದರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಜಸ್ಟ್ ನೋಡಿ ನನಗೆ ಆನ್ಸರ್ ಮಾಡಿ. First option is it involves chemical forces between adsorbent and adsorbate. Yes. It is irreversible in nature. Yes. It involves high heat of adsorption. Yes. It does not require activation energy. What about activation energy with the chemisorption? Yes, option D is correct. Good. Correct. Option D is correct. But activation energy is not applicable here. Okay. Activation energy is required only to get an intermediate. But here is our intention is to get a product, that is the chemical relation or chemical force between an adsorbent and adsorbate, that is it might be an exchange of electron or transfer of electron, okay, sharing of electron ಏನಾದ್ರೂ ಆಗಿರ್ಬೋದು. ಬಟ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ, activation energy requirement is not needed. ಬಟ್ ಇಲ್ಲಿ ಏನ್ ಹೇಳಿದ್ದಾರೆ, ಕೆಮಿಸ್ ಆಪ್ಷನ್, ಫಿಸಿಸ್ ಆಪ್ಷನ್ ಅಲ್ಲಿ ಏನು, there is no chemical relation between the reactant and the gas molecule and the solid surface. Whereas chemis option is very specific. Here there is a chemical reaction. In most of the cases we use the surface phenomenon in order to reduce the rate of the reaction, especially in case of catalysts. Catalysts provide an platform for the reactants to produce a product. But reactant in the product form ಆಗಬೇಕು ಅಂದ್ರೆ ನಮಗೆ intermediate formation ಏನಿದೆಲ್ಲ ಅದು ತುಂಬಾ important. Once we get an intermediate, soon after that we are going to get a product very quickly. Okay, so ಅದಕ್ಕೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ರೇಟ್ ಅನ್ನ ರೆಡ್ಯೂಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಟೆಂಪರೇಚರ್, ಪ್ರೆಷರ್ ಅಂಡ್ catalyst ಈ ತರ ಎಕ್ಸ್ಟರ್ನಲ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So that is also very important to get a reactant. ನೋಡಿ ಇಲ್ಲಿ reactant ಇರೋದು ಪ್ರಾಡಕ್ಟ್ ಆಗಕ್ಕೂ ಮುಂಚೆ intermediate ಆಗಬೇಕು. So this is highly unstable. In order to form this, the activation energy is required. But ಇಲ್ಲಿ it does not require activation energy ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Therefore, this is not applicable. Okay. Which one is not the characteristic of chemis option? Is not the characteristic. ಯಾವ್ದಲ್ಲ. Multimolecular adsorption. Yes, I forgot to tell you. See, chemis optionally always unimolecular formation irutte. Unimolecular adsorption. Since it is specific, chemis option is highly specific. It select ಮಾಡಿ ತನ್ನ ಕೋವಲೆಂಟ್ ಬಾಂಡ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಗೆ ಮ್ಯಾಚ್ ಆಗುವಂತಹ ಗ್ಯಾಸ್ ಅಥವಾ ಲಿಕ್ವಿಡ್ ಅನ್ನ ಮಾತ್ರ ಸೆಲೆಕ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಹೈಲಿ ಸ್ಪೆಸಿಫಿಕ್ and thus it forms only monolayer. Only single layer can be formed. Since physical adsorption is non-specific, it can form multimolecular adsorption. Therefore, not the characteristic. Multimolecular formation is not the characteristic of chemis option. It is the characteristics of physis option. Chemis option again of monolayer. Exothermic nature, yes, it is an exothermic process. Strong adsorption irutte and it is irreversible. Option A is correct. Okay. So which one is not the characteristic of chemis option? I think it is repeated. Yes, it is repeated. Okay. Gas masks containing activated charcoal to remove poisonous gases from atmosphere acts on the principle of. ನೋಡಿ ಇಲ್ಲಿ ಗ್ಯಾಸ್ ಮಾಸ್ಕ್ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ, this is mainly used in coal mining. So coal mining, while extracting the coal, the poisonous gases like carbon monoxide will be released. Okay, carbon monoxide release agate. If the workers inhale this in the larger amount, then they may die, because carboxyhemoglobin will be formed and it will be carried by the hemoglobin throughout the by the blood throughout the body. Then the person deoxygenated blood in the death ಆಗಬಹುದು. ಸೊ ಹಾಗಾಗಿ ಗ್ಯಾಸ್ ಮಾಸ್ಕ್ ಅನ್ನ ಕೊಟ್ಟಿರ್ತಾರೆ ಅವರಿಗೆ ವರ್ಕ್ ಮಾಡುವಾಗ ಕೋಲ್ ಮೈನಿಂಗ್ ಅಲ್ಲಿ. ಈ ಗ್ಯಾಸ್ ಮಾಸ್ಕ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, ಆಕ್ಟಿವೇಟೆಡ್ ಚಾರ್ಕೋಲ್ ಇರುತ್ತೆ. ಏನಕ್ಕೆ? ಟು ರಿಮೂವ್ ಪಾಯ್ಸನಸ್ ಗ್ಯಾಸಸ್. ಹೌ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ರಿಮೂವ್ಡ್? ಆಕ್ಟಿವೇಟೆಡ್ ಚಾರ್ಕೋಲ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಅಗೇನ್ ಅನ್ ಅಡ್ಸಾರ್ಬೆಂಟ್. ಸೊ ದಿಸ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಅಡ್ಸಾರ್ಬ್ ಆಲ್ ದ ಪಾಯ್ಸನಸ್ ಗ್ಯಾಸಸ್. Since it is a physis option, ಇಲ್ಲಿ ಏನೇನ್ ಗ್ಯಾಸಸ್ ಇದೆ ಅದನ್ನೆಲ್ಲ ಅಡ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. So from the atmosphere acts on the principle of. So that is adsorption. Option A. It is not absorption or sorption or all of this. It is option A. Right? Next. So adsorption due to strong chemical forces is called. Yes. Which may be the answer? ಯಾವುದು ಆನ್ಸರ್ ಇದರಲ್ಲಿ? Adsorption due to strong chemical force is chemisorption, physisorption, reversible adsorption, both B and C ಅಂತ ಇದೆ. Yes, which is the answer? Option A, correct. So that is chemisorption. Strong chemical forces are involved in the chemisorption, whereas physical, just weak van der Waals force of attraction. Next question. Catalysts are more effective in finely powdered state, colloidal state, rough surface, all of this. See, before going to solve this problem, I'll tell you the characteristic property of this one. Catalyst andre, that is nothing but you can consider this as an adsorbent, because catalysts are involved in the enhancement of rate. Rate of the reaction. Okay, so catalyst acts as an adsorbent. It provides a surface for the reactants to give products. So adu yavaga more effective agirutte? Finely powdered ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಸಿ ಈಗ ನೀವು ಒಂದು ಚಾಕ್ ಪೀಸ್ ಇದೆ ಅಂದ್ರೆ ಕನ್ಸಿಡರ್ ದಿಸ್ ಆಸ್ ಅ ಕೆಟಲಿಸ್ಟ್. ಇದನ್ನ ನೀವು ಇಂಕ್ ಅಲ್ಲಿ ಡಿಪ್ ಮಾಡಿದಾಗ ಇದು ಪೂರ್ತಿ ಕಲರ್ಡ್ ಆಗುತ್ತೆ. ಬಟ್ ವೆನ್ ಯು ಬ್ರೇಕ್ ದಿಸ್, ಕಟ್ ಇಟ್, ದ ಇನ್ನರ್ ಕೋರ್ ವಿಲ್ ಬಿ ವೈಟ್ ಇಟ್ ಸೆಲ್ಫ್. ಅಗೇನ್ ಅದನ್ನ ನೀವು ಮತ್ತೆ ಕಲರ್ ಅಲ್ಲಿ ಡಿಪ್ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ಅದು ವೈಟ್ ಕಲರ್ ಇರುವಂತಹ ಸರ್ಫೇಸ್ ಕಲರ್ಡ್ ಆಗುತ್ತೆ. ಅಗೇನ್ ಇಫ್ ಯು ಕಟ್ ಇಟ್, ನ್ಯೂ ಸರ್ಫೇಸ್ ವಿಲ್ ಬಿ obtained and again more and more liquid can be absorbed. So whenever you are going to cut, a new surface will be provided, obtained, and the process will be increased. Adsorption process can be increased. Therefore, the finely powdered state is more effective. ಅದು ನೀವು ಎಷ್ಟು ಕಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರೋ ಅಷ್ಟು ನ್ಯೂ ಸರ್ಫೇಸ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಸರ್ಫೇಸ್ ಜಾಸ್ತಿ ಆಗದಂಗೆ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೋಸೆಸ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ವೆದರ್ ಇಟ್ ಇಸ್ ಅ ಕೆಮಿಸಾರ್ಪ್ಷನ್ ಆರ್ ಫಿಸಿಸಾರ್ಪ್ಷನ್, ಇಟ್ ಡಸಂಟ್ ಮ್ಯಾಟರ್. Okay, and in case of colloidal state, yes, colloidal state andre force of attraction between the molecules will be reduced and unbalanced, more unbalanced, and in order to balance it more and more adsorption will be obtained. So therefore, then the rough surface andre nodi ee ರೀತಿ ಇರುತ್ತೆ. Not proper surface. Proper surface iddaga enagutte, the molecules will be arranged keenly, very neatly like this. Whereas if it is rough, it will be like this. So if it is rough, the spaces will be more, the availability of the surface will be more. Therefore, rough surface is also effective. Colloidal state is also effective. Therefore, option D is correct. All of these. Okay. So catalysts are more effective in all the three states. Which is not a purely surface phenomenon. Surface tension is a surface phenomenon. Adsorption is a surface phenomenon. Absorption is not a surface phenomenon. Therefore, option C is correct. Okay. Okay. So last but one question. Physical adsorption is accompanied by decrease in entropy of system. Okay. Then option D, decrease in enthalpy. The value of T delta S is negative. All of this. So this is related to the characteristic property of adsorption process, that especially physical adsorption. Okay. The physical adsorption is accompanied by decrease in entropy of the system. What I told is in the adsorption, delta H, delta S and delta G all are less than 0, that is negative. Okay, ಎಲ್ಲ ಕೂಡ ನೆಗೆಟಿವ್ ಆಗೇ ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಎಂಟ್ರೋಪಿ ಅಂದ್ರೆ ಡೆಲ್ಟಾ ಎಸ್, ಎಂಥಾಲ್ಪಿ ಡೆಲ್ಟಾ ಹೆಚ್, The value of T delta S that is related to delta G is also negative. Decreasing is nothing but negative value only. All these are negative. Therefore, all of these is right option. So this I told you in the synopsis. ಏನಾಗಿರುತ್ತೆ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಬಗ್ಗೆ ಹೇಳುವಾಗ ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೆ. ಓಕೆ, ಸೊ ಎಲ್ಲ ಕೂಡ ನೆಗೆಟಿವ್ ಆಗೇ ಇರುತ್ತೆ. Then last question. Which forms multi-molecular layer during adsorption? Yes, since you have studied the differences between physisorption and chemisorption, tell me the correct answer. Multi-molecular layer yaudralagate? Yes, very good, Subramanya. A, option A is correct. That is physisorption. Physical adsorption alli multi-molecular layer form agutte. Whereas in chemical it is monolayer. Okay, so this is about the today's session, that is the questions in surface chemistry. Then we will discuss some more factors which are involved in this chapter. Then we can solve the related problems.